Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad AQIL bin HANIP. My group and I will present about the electromagnetic compatibility on railway signaling system. So there's my group members, which is Muhammad AIMAN, RAMLAN and Muhammad FARIS HAZIM. So I'll gonna start first about this topic. So as you can see here, there's a X-Men character which is Magneto. Maybe it's related to the electromagnetic. So back to our main topic. I'll explain about the introduction about the EMC in the railway system. So what is EMC? EMC means the presence of electromagnetic environment that's not causing electromagnetic interference that may do some physical damage when they are surrounded with the electrical and electronic device. So that's about the explanation about the EMC. Now I'm gonna go to the what causes the electromagnetic interference. So electromagnetic interference can be known as EMI or RFI, which there is a presence of external circuit that can affect an electrical circuit, such as electromagnetic induction. Basically, induction occurs when the magnetic field move around wires, which will produce current, which can be seen in generator and motors. So there's two main factors basically in interference occur, which is electromagnetic induction and electromagnetic interference. There's two. Electromagnetic radiation, sorry. There's two. So I'll explain first about the electromagnetic induction. Electromagnetic induction is sometimes just can be called as induction. It's a process where a conductor placed in a changing magnetic field, or conductor moving through a stationary magnetic field cause the production of voltage across the conductor. This process of electromagnetic induction is cause an electrical current, or is said to be induced the current. So this picture shows the magnet solenoid and galvanometer. We have learned this back in our high school about this electromagnetic induction. So when the magnet moves through the solenoids, it will move the galvanometer. So there shows the induced current happen in the solenoid. So this shows that this experiment it can be related to the electromagnetic interference, such as in the electrical wires. So next, the second one about the main factor is electromagnetic radiation. So electromagnetic radiation, EM, is a form of energy of all around us and takes many forms, such as radio wave, microwave, X-ray, gamma ray, and many more. So sunlight is also a form of EM energy, and but visible light it's only small portion of the EM spectrum, which contain a broad range of electromagnetic wavelength. So this electromagnetic radiation consists of electromagnetic wave. Therefore, it can also cause the EMI, electromagnetic interference. So this below picture shows that the electromagnetic radiation spectrum, which have different frequency, which gamma rays, X-ray, UV rays, infrared, microwave, radio, and so on. So that's all about me. So I'll pass this slide to my other group member. That's all. Thank you.
Okay, my name is Muhammad RAMLAN, and I will explain about how AIMAN affects signaling system of a train and how to solve the problem. Okay, so how AIMAN affects signaling system of a train. The first one is Belize fault. The signal suddenly switched to red light in front of a train. Therefore, train had to commence an emergency stop. Then, after a short period, the signal indication switch off again. There were also cases where trains were also stopping randomly from 3 times per week to 3 times per hour in front of a red light. So, the second problem is automatic train control cause radio interferences. The detector was giving a false information and causing a misunderstanding between the train commander and the train direction. The train position switcher detector will indicate left position instead of right. So, there are some tests had been conducted and found that the detector was sensitive to many radio frequencies from DC to 300 MHz. So, moving on to how this problem can be solved. So, it is using a DC to DC converter for railway application. This converter could be used in many parts of railway systems such as track circuit monitoring, turnout condition monitoring, automated train control system, and etc. The normal DC to DC converter itself are a source of electromagnetic interference that emit huge energy which propagates by radiation and conduction over system signal and power lines. Thus, with DC to DC converter for railway applications, there are some features such as AMI filtering and soft switching in order to meet electronics equipment international standard of EN 50155. So, how does it work? From EMI filtering, this product is having an excellent EMI performances by upgrading the noise filtering technology that helps to improve overall system of EMI performance on conduction and radiation emissions. For example, this technology will filter the conduction and radiated emissions so that the signal does not exceed the noise limit that will meet regulations of EN 55011 of Class A. So, the second one is the soft switching. For the soft switching, it will reduce switching loss when converter operates in high frequency, so that during switching there will be zero current and voltage losses. Therefore, when high rates of change is reduced, EMC will also be reduced. So, this is the example of effects on hard switching and soft switching. Thank you.
Assalamualaikum warahmatullahi wabarakatuh. My name is Muhammad FARIS HAZIM ROSLAN. I will present the target market, the solution provider, and the unique value proposition. So, therefore, we take a look at the target market first. We have 3 companies that has experience in manufacturing and supplying the in Malaysia railway industry, such as Bombardier, Alstom, and Hyundai Rotem. Bombardier is a Germany-based company. It is a world-leading manufacturer in trains and planes, and they have expertise in equipment, mainline, and signaling system of a train. The example of the past project of Bombardier in Malaysia is the Malaysia Mass Rapid Transit. Next, Alstom is a French multinational company. It covers the complete system of railway technology, such as the equipment and the signaling system, and they also supply various types of rolling stocks, such as the AMU. Hyundai Rotem is a South Korea company. It is part of Hyundai Motor Group, which is well known in the industry. They're focusing on high-speed train, and their main focus is on signaling and communication system. So we move to the solution provider. Solution provider is a possible company that manufactures DC-DC converter that can be supplied to our main target. So
The first solution provider is the Monsun. Next, we have Min-Max Power, and third, Trico Power. Both of these three companies have manufactures DC-DC converters. So first, we start with Monsun. Monsun is a company based in Guangzhou, China. It has annual revenue of 67.5 million. They specialize in magnetic isolation, in power grid, transportation, and medical. And they pay high attention to environmental protection in their product and services. Next, for Min-Max Power, it is based in Hudson, Massachusetts. They have 27 experience in designing and manufacturing converters. They have a wide range of DC-DC converter types, and finally, they promote screen product. For Trico Power, they are a Switzerland company. They have the longest experience in manufacturing DC-DC converter, which is 37 years, and they have a high reputation in the global market, which means I believe they have the high quality product that the customer will be satisfied. So we now move to the product comparison of DC-DC converter that have been offered by the three company, which is Monsun, Trico Power, and the Min-Max. This table shows the 20 watt DC-DC converter for each company. We have, for the efficiency, the higher the better, because when the efficiency is high, the power loss is low. So for this, we have 80% to 86% for Monsun, 85 to 89% efficiency for Trico Power, and 88% for Min-Max. Next, we move to the isolation voltage. Isolation voltage for the Monsun is 2250 voltage direct current for 60 seconds, 2250 VDC for 60 seconds for Trico Power, and Min-Max 3000 VDC reinforced. For short circuit protection, three of these companies have the short circuit protection, which means that when there are short circuits happen, their product will not be broken. Next, we move to the EMC immunity. EMC immunity is the international standards that have been set so that there are no electromagnetic interference in the product. For example, the EN61000 and EN50121. Next, we have fire protections. We can see that the only company that offer the fire protection testing is Min-Max Power. Same goes to the fully vacuum encapsulated and remote control. Now we take a look at the benefits. For benefits, we have a certified application, warranty, experience, and technical support. All these three companies need to have the EN50155 because it is the international standards for designing and manufacturing an electronic device for railway applications. So that's why in the applications column, it is all railway. Next, we move to the warranty. The warranty offered by these three companies is the same, which is 3 years. Warranty for me is very important because if the product is broken, it could be repaired by the manufacturers for free. And for experience, Trico Power have the longest experience, which is 35 years, compared to Monsun 16 years and Min-Max Power 27 years. And for my opinion, their experience in manufacturing and supplying something like this product will affect the quality control for services they are given to us for the customers. Next, all these three companies also have technical support. So, from the features and benefits from the three companies, which one will win our heart? The winner is the MinMax Power. This is because they have three extra benefits that the other two companies didn't have, which is the fire protection testing, fully vacuum encapsulated, and remote control. Fire protection testing is very important because the case of the device can withstand high temperature. So when there are fire incident happening in the train, it can withstand the temperature and maintain the working principles in the device, so that the device can be used next for the installation. The second features MinMax Power offer is the fully vacuum encapsulated. It means that the device, the product is fully resist of water and dust, and it is also shockproof. This is very important because when there are circumstances of workers installing the device in wet and dirty environment, the product can be broken. And lastly, remote control. Remote control sounds like simple tools, but it is not. It is very effective when you want to controlling the output of the DC-DC converter from far away. For example, from the control room, you can choose any DC-DC converters in the train, and then you can adjust the output power. And because of that, I believe MinMax Power have won our heart. And that's all from us. Thank you.